So where can we go from here? Well, now that we're managing this infrastructure via Terraform, we get access to do more Terraform things. One such thing is I don't have to hard code all this stuff anymore, right? The security group ID, the key name, I don't have to hard code this stuff. I can actually interpolate it from other Terraform resources. So instead of doing hard coded values, I can start using Terraform itself to get interpolated values. So I'm going to do that. And since I'm using Terraform, I can start to output like certain pieces of data from my configuration so that you can use it in other, like in your pipelines, or you can have other Terraform runs use it. But for me, I just want to print the address to my application, right? So I'll just do http:// and then AWS instance dot app dot public IP. Cool. If I run Terraform plan now, you should still see no changes, but you'll see that then output now is here. So I'm just going to go ahead and apply this. And hit yes. Boom. And now I get my app URL. I can hit it, go right to my app. No more going into the AWS console, finding my IP, blah, 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 going through it. I get it now right in Terraform, and it's right there available for me or whoever wants to use it. So cool. Now that I have that, how can I make my first step to towards an immutable future, right? So let's talk about mutable versus immutable real quick before we do anything. We've already covered that mutable infrastructure is infrastructure that's created, and then you constantly mutate it to deploy your apps and get it to the state you need, right? We discussed some of the drawbacks there with like dependencies getting out of order, deployments taking a long time, deployments failing midway and leaving you in this weird gray zone. Those are some of the drawbacks. What does an immutable future look like? Well, an immutable like infrastructure is a paradigm where when you deploy your infrastructure, the app is already on there, right? You don't deploy infrastructure and then mutate it to get where you want. You deploy the infrastructure with a specific version of the app. And if you want to upgrade that version of the app, you completely destroy the infrastructure and deploy a new version with your new app version, right? Benefits? Well, my patching now moves down like upstream technically, right? My patching moves closer to the deployment. So no longer am I patching my OS every time. I am patching it before I deploy, right? I'm shipping a patched version. I also get repeatable deployments because if I build my app first and then build it into an image and then deploy it, I get the ability that if I were to deploy it again and again and again, it's going to be the same version of the app, right? Version 1 deployed today is still going to be version 1 deployed a week from now, right? Because I'm building it up front and deploying it as an immutable object. So how can I use Terraform to go in that direction, right? I already have this installation script here that I was using via SSH and installing Nginx and doing my thing. How can I continue to use something like this with Terraform? Well, Terraform has what are called provisioners. So if I go into my main.tf and I go to my AWS instance, I can tell this instance to provision itself, right? And I do that with a provisioner block. So I can do provisioner file. Which file do you want to copy to the source, to the destination image? Well, I want to copy sorry, my typing is slower than my brain. I want to copy the install.sh script. I want to take this and I want to copy it to my instance. Once it spins up, I want to put it in temp.install.sh. Install, beautiful. And now that I have a file there, what do I want to do with that file? Well, I want to run some commands. So there's a remote exec provisioner that will connect to your instance once it's up, run commands over SSH. So it's kind of like an Ansible setup, but in Terraform. And we'll see why this is good and why this is bad after I write it all up and deploy it. So I'm not even going to play around with this. I'm just going to copy this one. Beautiful. So we're basically going to give it execute permissions, execute the install script, and then remove it when it's done. And this is great and all, but provisioners by default, they don't magically connect to your instance. You need to tell it how to connect to your instance. So I'm going to create what's called a connection block and tell my instance or tell my Terraform config how to connect to this instance. It's going to use SSH with this user, with this private key, and you're going to connect to this IP address. Cool. With all of this added, I should be able to Terraform apply, and you should see nothing happen, right? And you might be wondering like, hey, Matt, you just defined a provisioner. Like, why didn't it run? This is the first step towards immutability. Provisioners don't run on every apply. They only run on the apply that creates the resource that they're attached to. So in order for me to have this provisioner run, I have to destroy this infrastructure and recreate it. Immutable deployments, right? Let's see what that looks like. So I'm going to modify the install script to do, I'll just call this like, 4.0 and then provisioner. And then if I want to, I can replace my instance using Terraform's replace directive, which is newly added in, I think, 1.2. I forget the version of Terraform that they added this in, but I can say, hey, I want you to replace my AWS app instance. And you'll see Terraform says, okay, great. I'm going to destroy this and I'm going to recreate it. And let's see what happens here. Yeah, Bill, I see you raise your hand. Or well, I got a notification that you raised your hand. So I don't know if you meant to do that. Made a mistake, sorry. Don't do it again. No, I'm just kidding. So now my infrastructure is being destroyed. So if I go into my AWS console, you'll see that the old instance, which was 03F blah, 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 has been destroyed, which is right here. And a new instance called 099 is being created in its place, right? And now you'll see it's provisioning with the file provisioner. It's uploading my install.sh script to the remote server. It's now running that script. It's installing Nginx. It's dropping the file. It's going to start Nginx, right? And you'll see something that I actually want this to happen. You see how this failed? This is actually an interesting problem because even when you use provisioners like this, you still have a deployment process that happens after the infrastructure was created, right? So even though I'm using Terraform and I'm using these provisioners, I still have this moment of time from the period that the instance is launched to while my provisioner is running that things can go wrong. This is one of those things that can go wrong. So I'm going to rerun it again, redestroy it, recreate it, and show you like, it passing, hopefully. This is one of the drawbacks that I want to discuss about this approach and why we're going to go to another approach afterwards. The buttons move when you open up chat. It always gets me. Oh, yeah. How does Terraform know the provisioner order? They run in linear order. So the provisioners that you define in the configuration run serially. So I did the file first and then the running the script. Doing its thing. And I want to let that give it time to do it again. It's funny because we have CI/CD pipelines that like sometimes use provisioners and sometimes don't. And every now and then we'll get that failure where it's like, hey, couldn't run dpackage or something. There's a lock on the file. So I'm glad that this happened live because it shows a pain point. Cool. So this one did not have that error, right? There was no issue there and it went successfully. And now my app has been provisioned. And if I open this URL, I should see my app, boom, with the provisioner all there.